uh, now today actually I was thinking that uh, our syllabus is over. Today's class will be the last class. That way I think we can go ahead and uh, last lecture I have already uploaded in the video lecture, magnetic circuit 2, where the series parallel circuit is explained. Do any one of you have any question from there? If no, then we will go today with the air gap problem. Now, if you want, then I can go ahead with this. Look at it.
Yes.
So this is the part 2 magnetic circuit video uploaded in the BUX and told you to go ahead with that. I hope that you have gone through. So my question is, if I run this just like this, can you follow? Hello, everybody. This is magnetic circuit part 2. Okay. All right. So this is the video I'm talking about. Now, this video I told you go through, and if you have any question, maybe we can discuss it today in the first part. And if you're okay, then I will switch to the last topic on magnetic circuit. That is today's topic. We're going to talk about the air gap. So air gap will be the last topic of magnetic circuit, and that's it, the syllabus. Now, regarding the magnetic circuit part 2, this video lecture I'm talking about, if you have any question, you can tell me, because at the beginning I have, if you look at it, the problem 2 is solved, then problem 3 is solved, and then we have gone through the series parallel circuit problem after solving this. If you can go with me, you can see. And this one thing is here, this is the BH curve. I'm going to send you by email the BH curve, and you can use that soft copy, or you can, from the book, you can follow as well in order to solve the problem. And in the exam, if any question come from a magnetic circuit BH curve, the BH curve will be attached with the question paper. So you don't need to worry about it, but still you should have the BH curve with you, the soft copy. I'll send it to you by email. I'll not get it, just one of you send a reminder, I'll send it. Okay, now let's come back to the next one, how to use these things to solve this problem. This is clearly shown in this video, and I hope everybody understood it very clearly, how to solve this problem. Now, problem 3 after that is solved. This is also you all understood very clearly, I assume, from this video lecture. So these two problems, after solving these two problems, then we jump to the next problem, which is the this one is a series parallel circuit. This is actually the magnetic circuit part 2 main component. After solving that, how to, there are two parts in magnetic circuit for your information. One part is the series parallel circuit, that is this one. Another part is your air gap part. So these are the main two parts of magnetic circuit. After learning this couple of classes, you are going to conclude. So you can expect also the question from series parallel circuit or air gap circuit, as today I'm going to show you. So these are the two part from magnetic circuit you have to understand very clearly and carefully. Now, tell me, and this one I have shown you also in this problem, how to solve it, and you saw that how to find the solution to this problem over here. Okay, so here it is, you have to find the number of turn, but it may be for some other as well, for find the current or the number of turn, whatever, but the methodology is same. The main thing here is to understand the series parallel equivalent circuit, and then you solve through the KVL KCL, and you can easily find the solution. And I hope that most of you understood this problem as well. I think these are the part 2 main thing. Now I assume that you have gone through, and understood it well. If you have any question regarding this part 2 video, then
Thank you very much.
I can show you and explain to you if you have any confusion or any question. Now, anybody got any question? Then I'll jump to the new topic, air gap. That's the last topic. I'm talking about magnetic circuit 2 video lecture. All of you understood clearly?
Sir, in this video, I also have another question.
Yeah, go ahead. Which one?
Sir, problem number 2.
Problem 2. Okay, this is problem 2. Where is your problem?
Sir, my problem is that that L, B, C, D, E. It says it's 5-inch. Sir, how did this 5-inch come?
Okay. The problem 2, I haven't shown the problem 2. Just a minute. This one.
Yes, sir.
Okay. So you are saying, okay, the blue one, the cast iron.
Yes, sir.
Okay, cast iron. BE, BE is 2.5 and BE is another 2.5, right?
Yes, sir.
So you are talking about the cast iron full length.
Yes, sir.
Can you tell me BC, DE?
Yes, sir. That is 2.5, 2.5. That's the 5. But, sir, shouldn't it be 2.5, 2.5 plus
4.
4 inch?
4 plus 4.
Sir.
Okay. Farhan, it is actually mistakenly I have written 2.5. Can you please correct it? This value, actually, I'll send you the what do you call that, lecture sheet, and you can see the real problem over there. Then you can understand. Okay, I'm going to show you on the screen also. This will be not 2.5 actually. This will be 0.5. Actually, this is the main thing happened, mistake here. Okay, can you see the screen now? Can you? Yeah, this is a good point. Have you seen this screen, Farhan? Can you see?
Yes, sir.
Okay, LBCD is 0.5 inch, not 2.5. Can you see 0.5, my cursor?
Yes, sir.
Yeah, can you please, all of you, just correct it. It is my mistake to write on the question. That is 2.5 I have written. Actually, the value is 0.5. So if it is 0.5, 0.5 is 1 and 4. Altogether, it is 5. Now it is okay.
Yes, sir.
Yeah, it's a question I have written mistakenly the wrong question, but actually it will be 0.5, not 2.5. And good, thank you very much, Farhan. I understood that you got the real problem. Okay, all what you have to do, very carefully understand. First, from the magnetic circuit, you have to draw the equivalent circuit. Every problem 2, problem 3, everywhere you saw equivalent circuit, the magnetic equivalent electrical circuit is the first job in the magnetic circuit problem, and you have to do it correctly. After that, you have to write your KVL equation, and that one you have understood, I assume. So same way, also the final problem, that is your series parallel problem. Here, this is the magnetic circuit. First thing is you have to draw the equivalent circuit. The last problem 2 and problem 3 you already understood how to draw the equivalent circuit. So you apply the same knowledge over here and you can draw the equivalent circuit. And for that, you can see the equivalent circuit is drawn here like this. Okay, this is the equivalent circuit up to do in series parallel. This is your series parallel magnetic circuit problem. Okay, this is one of the part which is the ultimate goal we had. So I hope that everybody understood the series parallel. After that, all you have to do is just do the normal calculation, finding the value of HC from BC and all this stuff. All you know. And another thing is, current summation rule, phi t equal to phi 1 plus phi 2, the total current divided into 2, current division things. You all understood, I hope that. And Okay, I think everybody should understand the magnetic circuit part 2. Other than this, if you don't have any question, then we can jump to today's class. Should be fine. uh, if you have gone through the video and if you don't have any question, then I can switch to a topic today that what we are going to discuss. That one is very important, I'm telling you, these two topic, because the final exam question will be coming, one of the question will be coming from uh, either series parallel magnetic circuit, or today what we are going to learn, the magnetic circuit, air gap circuit. So I'm sorry, air gap circuit or these things. Today's topic or last topic, both are important. So we are going to start now then with this topic, that is your air gap system. Now let's go to the today's topic, a magnetic circuit, air gap. Now if you go with this air gap system, you see uh, this thing over here. Okay, this is the, okay, I hope that you can see the thing. This is the air gap. Okay, if you see this picture, which is giving you the flavor of presence of air gap in the magnetic core. Now, in reality, you can see in the transformer or some sort of other type of core where the wire is wounded. So you can see core is having some air gap in practical field or in practical life. So if there is a air gap, we can keep. It is just required to control the what do you call that, flux lines flow. So it depends on how much you want to control that, just increasing some resistance, think like that way, in series. That's the air gap, and without any payment. You are not going to pay anything, you are just cutting the thing and you are just going to adjust it with the air. So it is not like a different type of core you are going to use here. You are just cutting a part of the core and make a air, so that you are adding some reluctance, and then you can control the, like in series you are going to add some reluctance. So this is the main target of air gap. Now let's come back to the point. If air gap is present, it is the same thing. You can imagine air gap is present means another core is present inside the gap. So what will happen then, the two core will be in series and you have to draw in series like that. But what is the difference between this? That is what we're going to talk now. If it is air gap and if the current is flowing through the wounding through the, and if the number of turn is n, if you think like that, then I and n is the magnetic force applied and the phi is produced. This is the phi produced over here, and the flux lines is going through the core. And how the flux lines are going through the core is this way. You know that already, I told. And this way it comes, it comes, it comes, it comes, and then go. So this is the flux lines is going to produce and flow. What happened in the case of air gap, over here also some, over the air gap here, over here also the air flux lines will be flowing through this path. I mean through the, okay, I'm going to go the green line. So over here also the flux lines is going through, but it is the same flux lines going through that. Now if this one you can say that is a phi g, this is phi g, and the flux flow through this is phi core, and or I can write here phi core, phi core. So this phi core and phi g, it is the same flux lines flowing through, like a current electron flow. So how much electron is flowing through the core, so that is the same number of phi g will be flowing through that, because again it have to constitute another phi core. So phi core is enter into the air gap and then out from the air gap, and again it is phi core. So phi core and phi g must be same in that case. So you can say that a phi core which is coming through the core will be nothing but equal to phi g, that is going through the air gap. And you understand it because the number of flux lines flowing through the core, if you go through a three-dimensional graph like this, and then you can see this one coming like that, for example, then what will happen, you can see all the flux lines are passing through this flowing just like a shower, the rain through the what you call it, through a pillar, through the pillar, so all the flux lines are coming from the top to the bottom, just like shower, right? It is going through like this, so it is just like a shower flowing through the top to the bottom. And so you can just cut the thing here. If you cut the thing here, area of the air gap, and that the shower, the flux lines are flowing, that area also you can see is something like a square area where the flux lines are going through, and the area of cross section here will be also AG for the flux line. And if you cut the core anywhere, because it is throughout same, if you cut the core anywhere, and the core area, if you find a core area over here, you can see the same core area as well. And this core area and that flux lines area, these are also same. The AG and A core will be same. So the cross section through the air gap and the cross section of the uh, core will be also same. So we can say another thing here, that the AG, A core, also will be equal to phi AAG, that is the uh, air gap cross-sectional area through which the flux lines are falling from the top to the bottom. Okay, this two area also same. Now if this two area, cross-section area, that cross-section area are same, then flux lines are same, then we can say for the core, we can say the core uh, flux density B core will be what? B core will be phi core by A core according to formula phi core by A core. And the air gap flux density, if I want to say that Bg will be what, then same way Bg will be phi g by Ag. So if your this phi core and phi g is same, and A core and Ag is same, phi core and phi g Ag is same, then we can conclude from there that B core and I'm sorry, B core and BG will be also same. This thing we can conclude from this air gap uh, presence in magnetic circuit. If the air gap is present in the magnetic circuit, then we can say that the core flux density and the air gap density is same, because the core flux lines and air gap flux lines are same, core area and flux lines area, cross section area are same. So we can say B core equal to Bg. Now my question here to you all, same way shall I say the same thing, that H core, the magnetizing force for the core, will it be equal to uh, Hg or not? That is a question now. All are same, but what happened to the magnetizing force? Is it also same? If you if you were asked this question, the answer is no. It is not same. This is the difference. Okay, just try to understand. Asking you all to try to understand this question. You drop out. So you don't need to learn air gap. You don't need to learn air gap then. Okay, if it is true, then when the electricity back, you just join. Okay. Okay. Otherwise, just go through the lecture. Okay. Video. Okay. Okay. I'm sorry. One of the student asked me a question. Farhan actually dropped because of his power supply failed, so he's out from the net. Okay. I'm sorry for that. Now let's come back to the point. Everything is fine. Hey, can you hear me?
Yes, sir.
Okay, good. Now look at it carefully. Why these two are not same? Because the magnetizing core magnetizing force and the Hg are not same. The reason is the H core is depending on different material. The value of the H core will be different for different material, because we are going to find the, look at it carefully, we are going to find the H core from the B core, and Hg we are going to find from the Bg. Okay, this is the way. And if I ask you, the H core should be found from B core, how? You already saw lecture 1, lecture 2, I mean part 2, part 1 you have seen, and now you can easily answer the question how to get the H core from B core. Any children can tell me what is the
Yes,
answer?
sir. From BS Cloud.
Absolutely good. From the BH curve. The H core you can get from the BH curve. And but the BG and HG, if I ask you this question, you cannot get it from the BH curve. The reason is that the two are coming different, and that cannot be equal. Now a question is how to get the HG from BG. It is also, you know very well from lecture 1. Lecture 1 said what? The relationship between BG and HG is B equal to mu H. Remember?
Yes, sir.
Yes, good. So this is the formula you have to go for B, or it is a general formula, but for in case of G air gap, it is BG and HG, but the mu is a very special mu. That mu is actually I'm sorry, the mu is actually mu naught in this case. For air gap, the mu is very much constant, like consider it is the vacuum. So the vacuum permeability, that means most of the practical application, if you read it, can you see? Most of the practical application, the permeability of air is taken to be equal to that of the space or vacuum, free space or vacuum, which is mu naught. And that's why the Hg is coming through the relationship as a Bg by mu g. So Bg equal to this. From here, if you go, then you can find Hg equal to Bg by mu naught. And that's what the Hg you can calculate from. And can anybody remember what was the value? I told you what is the value of mu naught. So
Yes, sir.
yeah,
4 pi into 10 to the power minus 7.
good, very good. So remember, this is what you will not be given in the exam, this value. So it is your responsibility to remember it, that Bg divided by 4 pi 10 to the power minus 7. So this is what the value you calculate from here. So whatever the Bg you are getting from this, and that value you can substitute here and divide by 4 pi 10 to the power minus 7 is fixed value, you can easily get the Hg. So for Hg from Bg, you don't need to go to the BH curve. You can straight away get it from the equation. This is the equation. But for H core, yes, you have to go through the BH curve. Okay, so your Hg and Bg, I'm sorry, H core and Hg, I'm talking about this dot, cannot be equal. It should be different from each other. So for all are equal, A core Ag, phi core phi g, B core, BG. But when you're going to find H core and HG from B core and BG, it is coming in different way. One is coming through the BH curve according to the construction material of the core. Another one come from the equation, which is standard 4 pi 10 to the power minus 7. You have to multiply with that. That's the way to go to do the job. Now, based on this idea, we are going to solve a problem. That problem is a very important problem for us, and all of you need to understand it also. Now, look at the problem. The problem is this. This is an air gap problem we are going to consider to solve today. And if you read it, all of you can get a snapshot of this thing. Okay, if you read it, what is the question said? Find the magnetic flux. All of you please keep ready with your calculator because you have to do a lot of calculation today. And all of you have to answer if you want to get a bonus point, and you know that, so that it will help you for the quiz. Now, at a BH curve, do you have the BH curve with you? Hey, ducks. Hello, are you sleeping already? No. You got the BH curve or not? Let's come back to the point. Okay, so if you go first with this sort of problem, if you read the question, hey, can you please read the question? What is written here? Find the question said that find the magnetic flux phi for the series magnetic circuit shown below for the specified impressed MMF. What you have to find? You have to find the magnetic flux. This is what is the thing you have to determine. Magnetic flux means phi. The phi equal to what? So there is a question here. Find phi equal to what? So far, if you see, phi was given most of the problem, and you found from phi divided by a, you got the b, and you solve the problem from h and ting tang. But this time, it is an opposite thing happened. It is what you have to find is the phi. So what is the phi in the circuit if the 4 ampere current is applied to a coil of a magnetic core where their number of turn is n 100 turn. That a magnetic motive force is applied 4 into 100 is a 400. So 400 magnetic motive force MMF is applied 400, 4 into 100, applied on the core, and what will happen? Through the core there will be a phi produced, and that flux lines will flow through the core. And question is, what is that phi? It's a very straightforward question, you can understand. If you apply the MMF 4 into 100, that is 400. It's a MMF is what? Ni. You remember Ni. So which is 400. If you apply the 400 here, what will be the phi produced? That is the question you have to answer. Clear? Hey, all of you dead or alive? You should
Yes,
answer.
sir. Yes,
Good.
yes, sir.
Now, the other parameters are given. What are the other parameters? Other parameters are given here. The LC core is given, area throughout is given, and the air gap, how much length in the air gap, 0.01 meter also given. So the length of the core here and the air gap length, these two are different, remember. So the length of the core is, if I take the blue one, the length of the core is from here, from this point to go up to this point. So from here to here, without air gap, remember, L core is without air gap. But when the air gap is coming, this very small part, air gap, a very small part, air gap. And that one is given here as 0.01. this is the air gap for this, and this is the L core for this. Okay, so I hope that you understand these two lengths are different. If the total length, if you consider the L core plus air gap. So sometimes question comes the total, like you have 2 pi r, the radius of the circle is given. So what will be the periphery? Periphery will be 2 pi r. 2 pi r minus 0.01 is the L core. Sometimes L core will not be given directly. Maybe you have to calculate it from there. So that sort of things can be happened also. So you need to understand what is L core means. L core means without the air gap. So if you have the radius given of the circle, then you have to find the full periphery. Periphery is 2 pi r. The 2 pi r minus air gap is giving the L core. You have to calculate that one by yourself. And in this question, L core is given directly, air gap also given. So you don't need to do any calculation here. Okay, fine. Now, what should be the next thing? Next thing is, in order to do it, your first thing solution is you have to draw the what? Electrical equivalent circuit. I told you in the magnetic circuit problem, first job is to draw the electrical equivalent circuit. So I'm going to tell you once again the things given here. You have to write like this, maybe better. Given here, the area of cross section is given here, which is AC or AG, whatever you say, AG or AC, all are same, is given here. 0.03 meter square is given. Then your LC, the chord length LC or LG, LC is given here 0.16 meter. Then your LG is given here 0.001 meter. These are the things given, and your number of turn is given here 100 turn, and current flow through the coil is given as 4 ampere current. Okay, these are the parameters given, and you have to find this. You have given this. Now you have to go for solution. Now to go for solution, as I told you, first thing first, what is that? You have to draw the electrical equivalent circuit. If you want to draw the electrical equivalent circuit, then this is the source, that is magnetomotive force, and the L core is the FC, and the air gap core is the FG. These are the three magnetomotive force you are going to see here. So if you want to plot it, then your solution will be coming like that. FG is the magnetomotive force applied. This is plus minus FG. F you are applying, and reluctance, one is your FC core, another FG. So you can just finish like that, FG, FC. And a phi is flowing, which is phi C is equal to phi G. Same thing, which is phi. So the phi is the same phi. You can see from here is a flowing. So you have this thing coming there, plus minus, plus minus. So you can easily apply the KVL. KVL gives you the equation for F equal to FC plus FG. So you already come to know for a lot of problems you have done already. So you got Ni equal to FC is the SC magnetizing force, LC plus SG LG. So this is the equation you can get from the KVL from this magnetic circuit. All of you understand up to this, I hope. Now in this equation, what happened if you find the value, substitute the value, you know the N value is given and I value is given. N is I, if you multiply, what is the value? Hey, N into I,
400.
400. I hope that everybody understand it. I'm not going to explain. So 400. And then you are getting the SG. SC and LC. Now LC, yes, you can. I'm just writing it a little bit from the left side, some more here. Okay, so it's a 400. I'm writing here 400 equal to HC. HC is what? HC is not given. LC is given here. LC is what? LC, if you go, LC is given here as 0.16. So you get here 0.16 plus HG is also not given, but LG is given. LG is what? LG is given here as 0.01. 001. Okay, this is what you already got. Now HG and HC, these two guys are the question coming here. Okay, now if you know what is the HG value, and means you can get the value of B and phi. And for there are how many unknown here in this case? What is your idea? How many unknown?
One.
Hey, come on, one unknown. You dumb.
Two
We can
unknowns.
just take
You
5.
do no. You. How come you get the value of H? Can you find the value of HG and HG? You cannot, because what is the value of HG? What is the value of HC? Is it given here? Or can you find it? How can you find? You need the B, and you can then BC or BG, then you can apply the BH curve, or you apply the, oh, I'll talk about it later. But I'm just talking about, if you want to go for BG, BG is your phi by BC, for example. I can just tell you. For if you want to know HG and HG, then you have to go for BC. BC means what? Phi C by A. Phi C by SA. Okay, then you can, from here BH curve, you can find HC, then you can jump straight to that. But do you know HC, Phi C?
No.
No, you know AC, okay, fine. You can find the value of BC. If you know Phi C, you don't know. Why? Because Phi C, what you have to determine, it is not given. It is what you have to find. So if you do not know Phi C, you cannot find the BC, you cannot find the HC. Same thing happening there. The BG will give you the value of HG, but BG, do you know? If you want to find BG, you have to find phi G by AG. For phi G, is it given? No, because phi C, phi, you already know that phi equal to what means? Phi equal to means what? Phi means phi C, phi G, same. Phi C, phi G equal to what? Same thing. So phi G and phi C is not given. That's what you have to determine. So you cannot find the BG and BC from here because you don't know the phi C and phi G. And that's why HC and HG you cannot find. That's what I'm talking about. This HG and HC are unknown. That's why I put the two close to question mark here. Just I'm talking about. Try to understand my point. Two unknown, one equation. This is one equation, but two unknown. One unknown is your HC, another unknown equation is HG. So in one equation, two unknown, can you find the unknown value? Can you tell me from here, HC equal to what? So that you can find the BC, so that you can find the phi C. But can you find the HC from here?
No, sir.
If you can find the value of HC from here, then you can find the BC from BH curve, and then you can find the phi C from BC by BC into A. You can easily find the HC, and your answer is done. Or if you can find the value of HG here, then HG can give you the value of BG by throw mu 0. So multiply by 4 pi 10 to the power minus 7. And if you get BG, then BG can give you the phi G. Phi G means your destination is done. So you cannot find HG, you cannot find HC. None of them you can find from this equation. Because why? Because 3x plus 2y plus 1 equal to 0. Can you find what is the value of x, what is the value of y? Can you find from this equation?
No, sir.
Right. one equation, two unknown. You cannot. You need two equation for two unknown. Every children know. So two simultaneous equation is required. Now in our case here, same problem. In our equation, we don't know the value. We are having two unknown in one equation. Two unknown in one equation, we cannot find the value. But if we can find, then we can get the value of H straight away after finding the value of Hg or Hc, anyone. Now, what to do in that case? If there is one equation but two unknown, then how to find this unknown? This is a question to you all. What we have to do in this case? Try to understand. What we have to do, we have to go with some sort of trial and error method. That means we substitute the value of Hc and another value Hg, and we see this left hand side and the right hand side are becoming equal or not. Got my point?
Yes, sir.
Okay,
Yes, sir.
but we say that no, right hand side is much greater than left hand side. After some value, if you put, then you put another value. This one is something 100, this one is 200. Again, it is not satisfied. Then you put here, this is 50, this is 100, and this is 250. It is not satisfied. This is okay, it's 25, it is 375. It is not satisfied. Like that, trial and error. You are going to put every time different value, and then you get the, you see the equation is satisfied or not. If the equation is satisfied, that value is the value for Hc and Hg. Now, if you do it in the exam, then your whole day life finish, but you cannot come to a conclusion. Got it? Then how you answer the question? Only one question will kill all your time. So what to do in this case? So in this case, we have to apply a standard method. For this trial and error method, we have to start with a standard method, with a standard way in order to solve this problem. This trial and error method we have to apply, but we have to follow a standard way. Now, there is a condition given in the question that this is 400, for example, and if you get on the right hand side is 395, or you get 404. Got my point? This, if it is something close to each other, let's say equivalent, and 100% 400 equal to 400, it is not necessary. If you say 100 400, it is 100% accurate result, but it is not necessary for this question because it's not possible for human trial error determination. Now, if you look at the question carefully, all of you, what is written here? Can you see? Can anybody read what is written here? Yeah, this line under the, what is that written there? Anybody? The orange line. I have underlined with the orange color. What is the statement? Oh, you cannot read it, right? If you say no, then I'll read it for you. Hey, what happened?
So the print is hard to read.
Hard to read. Good. I was asking that. I'm just asking. Are you looking at the slide what I'm talking, or you are watching movie? That's what. Okay. You said hard to read. Good. Now I'm telling you. Can you follow me? The statement is in the question is, and in the exam it comes. Of course, it will be written very clearly. Everybody can understand. But I'm just telling you. Just follow me. It is written. Result will be. Result will. Sorry. Okay. Result will be tolerated within plus minus 5%. It is the statement. The result what you are going to find, the phi value, that phi will be tolerated if the result plus minus 5%, if the result is within plus minus 5% error. That means this difference should be within plus minus 5%. That means if the value is 395 or if the value is 404, then you have to check, yeah, it is within plus minus 5% or not. Let's say this is 400, this is not this, not this, it is 500. Okay, if it is 400 and it's a 500, do you think the error difference is within plus minus 5%? Hey, what is the
Yes,
error?
sir.
No, sir.
No,
No,
sir.
because error is 100, because out this side, right hand side 500, left hand side 400. So it is not within the range. But if it is 395 and it is, or it is 404, yeah, if it is 395, you can say yes, it is okay. It is plus 5. It is within plus minus 5%. Where this is plus 5% and minus 5%. It will be within plus minus 5%. Either this or the both are accepted. But if it's a 500, it is not accepted. This is what the meaning of this thing, that plus minus 5% is. But if it is 400 equal to 400, then what is that? 0% error, which is not required. But your result should be within plus minus 5%. It is acceptable. Okay, this is just a condition or constraint I'm telling you. Now, how to get the result and then how to check your result is within the error or not, that one we'll see later. Now, let's come back to the point. We are now going to do the method, how to apply the trial and error method. That one I'm going to show you now. So first thing what you have to do, this is the first step you have to do. Let all the MMF applied, okay, I'm writing it here, all the MMF, I'm writing in the next page, the better. All the MMF is applied on the air gap. Applied on the air gap. If you assume that, that means your MMF, all the MMF is what? All the MMF is NI, this is 400. All the 400 is applied to the FG. So in that case, we can write this FG, F will be equal to FG. That means your NI, all the NI is applied on the FG, mean SG, LG. No core. If it is as assume first, then from here you can find that N into I is 400 and SG you have to find, and LG is 0.001. So from here you can find the value of SG, which is 400 divided by 0.001. Can you tell me what is the answer coming? How many zero? 40,003?
5, sir. 50.
50. Okay, this is what ampere turn per meter. The unit must be important. Okay, this is the first thing you have to do. That is your SG you are going to get, if it is assumed that first initially all are applied here. If this is the scenario, then SG is going to give you the BG, and a BG equal to what? BG equal to what is the formula? BG equal to what?
So B is equal to mu naught H.
Mu naught. That means 4 pi 10 to the power minus 10 minus 7 into SG is this 40,000. So can you tell me what is this value coming?
0.5 T.
Okay, good. 0.5 T. 0.5 T. So if it is 0.5 T BG, and we know that BG and BC is same, so it is BC also same. So BG and BC same means we can say from the BC what the phi C also. So phi C will be, can you tell me the equation phi C and BC? B equal to 5 by 8, then what will be the equation coming? BC will be, phi C will be what? Phi C will be BC into
DC into AC.
AC. So 0.5 into AC is given already. What is the value? in the equation. I told you already to get a snapshot. SC or AG is 0.03 meter square. It is given in the question. So 0.03. So what is the phi C?
Sir, 1.5 into 10 to the power minus 3.
1.5 into 10 to the power minus
3
3.
Webers.
Sir, AC will be maybe sir 0.003.
I'm
Sir,
sorry,
double
0.03. Right. Okay. I'm going to correct it. You're right. Okay. In that case, it will be will it be different?
No, sir, same. I
Same.
didn't.
Yeah, I made a mistake there. Okay. 1.5 into 10 to the power minus 3 Weber. You are getting here. Phi C. Phi C and phi Z are same. Please don't make a mistake here. Phi C all are same. So this is what phi C means phi. So you got the answer. This is phi. Our target is to find the phi. Where's that? Okay, just a minute. Our target is to find the value of phi, right? Phi is, what is the phi value? And we got the phi 1.5 into 10 to the power minus 3 Weber. So answer done. Go back home. Is it like that?
No, sir.
No. What you have to do with this answer, listen, the answer you got, yes, it is the answer. If and only if this answer can satisfy this equation. If this left hand side and right hand side are equal with this answer, if you can prove, then your answer is done. Now let us go and prove this thing. Okay, how to prove it? Hey, come on, you're making trouble. How to prove it? Remember, the left hand side is already 400. On the right hand side, we have to, right. For that, what you need to do is you have to find the value of HC and HG. Substitute these two value, HG and HC, these two value into this equation, and you find the result. And if this one is equal to the left hand side is 400, equal or within plus minus 5%, then your answer is done. Now the question is, what is the value of HC and HG? We are going to see from here. Now HG we already got, we had it here. On HC will come from BC. So BC will give you the HC. Hey, listen, BC will give you the HC because this is the HG and only the HC we need, and then HG and HC we can substitute into the equation. HC should come from the BH curve, and B is already you know, which is 0.5 Tesla. Now you have to find what is the corresponding HC from the BH curve. Hey, have you got the BH curve already by email?
Yes, sir.
Okay, open it. Now, one more thing, what I did not mention in the question because it was not given there, the material, name of the material is not written here. Can all of you note it down? The material, the core material is made of cast iron. Cast iron. This is the only thing missing here. All of you please note it down. The material, the name of the material is cast iron. Cast iron. Okay, good. Now if you can see, this is a cast iron material. I'm going to up. Okay, good. So if it is cast iron from the BH curve, now we have to go with the cast iron material. So if you go with the cast iron material, okay, where is that? Oh, it is not given, I think. Oh yeah, here we go. The BH curve. Okay, now if you go with the BH curve, hey, what is the cast iron? And what is the 0.5? Is it 0.5?
0.5. Yes, sir.
0.5. If it's 0.5, what you got?
Sir, 285 I got.
Okay, you got
I agree.
285. Let's come here. What I got? 0.5 is here. Where you got 285? 285. Rest of you, what is your answer?
Sir, 1500.
It's approximately
Oh, sorry.
1500 or more than that, a little bit.
1500 or sir 1600?
1600. Okay, fine. If you got 1600 also accepted, 1500 also accepted, but what I come the in between 1500 and 1600, I can consider that is your. If you go with that a little bit there and there, I'm going to take it as a 1500 in between two of you, 1550. So 1500, 1600, I'm writing here 1550. So let us call 1550 as the value of this guy. Hey, all of you take it by yourself. What will you take? Will it be 1500 or 1550? Any answer? Any other people? Hey, what happened?
So
Any other answer?
1550, sir.
1550. All of you agree? Because I need to
Yes.
know other people should tell what. Okay. If you say 1550, I assume that everybody agreed with your friend. The value is 1550. Even 1600 or even 1500, all are correct. So let us consider one, then our result will be same. Okay, can you make it 1500 to make it easy for everybody? No
Okay, sir.
confusion. Okay, let it be 1500, please. Okay, let it be 1500, not 15. Then it will be easy for everybody. Otherwise, confusion. Okay, 1500 ampere turn per meter. Okay, now if you put the value 1500 here, 1500, now go. Let's go. Hey, all of you, substitute the value of HC and HG here and find the answer here. If you can find the answer, raise your hand. I'll give you 1 bonus point. Please don't give me the answer in advance. Just raise your hand. Yeah, 3 participant raise. Okay, I'm going to call your name now. Okay, now who are the participants? What's wrong? What is this? Okay. Okay. Oh, a lot of participants. Okay, good. I am asking you first, Sajjad Hussain. Sajjad, tell me.
Sir, I have got 640.
You got 640. Okay, now you tell me first, what are the value, because you copied from your friends or not? Tell me what is the value of HC you written.
Sir,
Here.
HC value is 1500. Just we have calculated from BH
And
curve.
0.16 plus then
Then, sir, HG value is 4 into 10 to the power 5.
4 into 10 to the 5 into 0.001.
001, sir. Yes, sir.
Then you got 640.
And 40.
And this is 400. 640, 400. Is it equal? Oh, you cannot see that. Okay. Okay. Can see now?
Yes, sir.
Okay, good. Now, 400 and 640 is not same, and it is more, and error is there. Now the question is, how much error is there? We have to find the
Yes.
error, and that's a percentage error. If you want to find, then the error percentage coming here as 640 minus 400. 400, and the base unit is 640 times 100. What is that?
Sir, 37.
Yeah, now I'm talking about Sajjad to go it.
Oh, I'm sorry.
Sajjad, answer. And you get 1 point, otherwise no. You don't know how to do it.
Sir, I have done, sir. It is 0.375
Oh,
or
damn.
37%.
That is the thing. The 100 is there.
Yes, sir.
37.5%.
0.5%.
So error is it Sajjad acceptable?
No, sir, it's not
Why not?
acceptable.
Why not?
Because it is out of 5%, sir.
Good, excellent. It
Beyond
is
5%.
beyond outside the range or outside the tolerance range. So
Yes, sir.
it is not acceptable. So good. Sajjad will get 1 point. Just remind me later at the end. Okay,
sir.
good. And now what to do now in this case? The thing what you have to do now is you have to reduce the error from this is already having a big error. You can see 640 have to reduce. This is what our job now to do. Okay, now in order to reduce this 640, what we have to do is we have to reduce this phi c and hg, but this phi c and hg, it depends on phi. That phi, this phi is the main thing. If you can reduce the phi, as I told you last first lecture, phi reduce means b reduce, b reduce means h reduce. BH curve, how we have drawn the BH curve, there you can remember. So this phi now we have to reduce, and if you reduce this phi, then our h c and hg will be reduced. And in that scenario, how much percentage we are going to reduce, that one is a question here. Now from here we have excess 37, for example, but this 37 excess is from the Magnum-Mori force equation just satisfaction value, ampere turn value. So we have to reduce the phi. From here you have to get the idea. Let's say it is 37. So if you want, you can reduce by 37.5% phi. Phi can be reduced by 37.5%, but this is not the same thing. So you can normally every books you can see they also follow the approximate integer value, approximate value, but a round figure. Round figure means around 37, maybe you can say 35, maybe you can say 30%, like sort of things. So if you say 35% or 30%, both, anything can be taken. Even if you say I want 37.5%, I want to reduce. Okay, no problem. You can reduce 37.5% also, no problem. But normally in the books, they follow this sort of way. So a rigid number. So if you go for a rigid number, for example, we go for, let's say 30, 35, what do you call that, 30%. 30% if you consider is a good number, 37. So if you go for 30% reduction of phi, so you have to write here, this phi should be reduced by 30%. This phi will be reduced by 30%. 30% reduction for this phi. So if you reduce the phi by 30%, look carefully. If you reduce the phi by 30%, then what will be the new phi? Phi new will be what? After reducing the 30%, the phi new will be phi into what? 1 minus 0.3. That is 7%, which is, what is that value? What is the value was 1. Hey, what was the value? 1.5
1.5
or
into 10 to the power
3.
minus 3.
So you just write here 1.5 into 10 to the power minus 3 into 0. What?
3.
3.
0.7.
Dark.
0.7.
1.7.
What are you saying? Okay, now what is the answer?
1.05 into 10 to the power minus 3.
No, 1.5 into 0.7. What is that? Hey, what is the answer?
1.05 into 10 to the power
I'm
minus
sorry,
3.
1.05. Okay, 1.05 into 10 to the power minus 3 Weber. So this will be the answer. So you go back home? No, you cannot go back home, because this is the answer. You can say we got the answer. We got the answer and go back home. Yes or no? No, we cannot say yet, unless you can prove that the equation is satisfied with this new phi value. So you have to next prove it that it is within the range, it is equal within the range or not with this new phi. So how to do this? New phi will be satisfying that equation. Let's go back to that equation now, just to show you. The equation will be now, listen, equation will be now, carefully listen, look, HC new value with the phi with the new phi give you the HC new and HG new. Now these two HC new, HG new will be coming from the phi new, and that value you have to substitute here, and you can prove it is satisfying or not. So in that HC new will no more 1500 and no more 4000, 40,000. You have to find the value again, and then you have to find the error again. What is the error? You have to find it again. So you have to recalculate the whole things and the whole procedure again. So if you want to do it, what to do? What you have to find the value of HC new and then substitute here, HG new, substitute here. From that, phi new. Let's go to there, phi new. Phi new should give you the HC new. How? Hey, listen, you have to get the phi new should give you the B. That your, let's say phi new, BC new, or BG new. BC new will be coming from this phi new. Phi new means phi C new, phi G new, all are same, you know that. So what will be the BC new? Who can find it and tell me? Raise your hand and get the answer and tell me. All of you please find it and raise your hand. Okay, you found it, one guy. Who are that? Who is that guy? Just a
Sir,
minute.
I found it.
Okay, I cannot access. Let me just access the thing. With a little bit problem I'm having. Okay, just 1 second. Okay. Yes, sir. Who is the guy? Now, oh, 4 people. Jihad, Burhanuddin, Isa Islam, and Fariha Khan, Sajjad Hussain. Okay, now, hey, what happened? Okay, I'm asking who did not get marks yet? Jihad, Isa, Fariha, Sajjad. Burhanuddin, why you drop it down? Okay, I'm asking Jihad, you got any
Yes, sir.
marks yet?
Yes, 5.
Okay, Isa Islam, how much?
Sir.
You don't know?
No, sir.
Oh, you are not. Okay, Fariha,
No, sir.
you also don't get any. Sajjad,
Yes, sir. I have got.
today you got one also, no problem. Okay, now let's come to Isa Islam. Isa, can you tell me what is your answer? BC new.
0.35 Tesla.
0. Tell me the equation.
1.05 into 10 to the power minus 3 divided by 0.003.
Good. 1.05. 1.05 into 10 to the power minus 3 divided by
0.003.
0.003. Good. And what is the answer?
0.35 Tesla.
35 Tesla. Now, last question for you, then get a full 1 mark. This BC new should give you the HC new. Another half mark here. How you get it? Isa.
From the curve.
Exactly. You do have the curve. I sent by email.
It's 850, sir. I already got it.
850. All of you agree with him. 850. Or a different value you got?
900.
You got what?
Sir, it is close to 900. It can be taken, sir.
Okay, it is close to 900. And you said 900 and Isa said 850. Any other student can give me the answer? Any answer?
Sir, I am taking it as 700.
Okay, it is 700. like that sort of way. Okay, now let's come back to the, okay, I'm going to see the thing. Okay, you can see, right? Okay, here, 3.75, 3 point, hey, what is that, Isa? 0 point, 3.375, right?
0.35.
0.3, 0.375 or 0.35?
Sir,
0.35.
0.35.
Okay, 0.35. So 0.35 is very close to it. Okay. Okay, you are saying 700, 600, 700. Okay, it is 600, 800. So 750 will be very much close. Okay, I'm taking it as 750. Whatever you got, you can keep it, no problem. It's not very much that much different, but 750, if you go for the first problem, I think let us all be same, that will be better. Can you please all consider the same value? Sajjad, I'm sorry, Isa, your answer I am accepting, but you write it here 750 for your calculation. But I'll give you full marks, no doubt, but you please consider 750 and then do the calculation. All of you, please follow this. Okay. Now, if it is 750, we are getting the HC new as a 750, and look at it. We are going to the equation, and here you put 750. This is 750 you are going to put. Good. And now HC new, HG new. What is this value? Now we have to find it. Now I'm giving it up to you. Anybody, please raise your hand. What will be HG new? Anybody done it? Tell me.
Yes, sir.
Yeah, raise your hand. Let's see how many of you raise hand. Okay, 2 of you, Jihad and Isa Islam. Okay, now Jihad, go with the answer.
Yes, sir. So its equation is 0.35 divided by.
Equation is what? HG equation is what?
Yes, sir. Equation is 0.35.
No, it is the value you put, but I'm talking about equation.
Okay, sir. B nu by mu naught.
BG new by
Mu naught.
mu naught. Good. And BG new is this one.
0.35, sir.
Remember, BC new and BG new are same. So 0.35 divided by
4 pi into 10 to the power minus 7.
minus 7. And then what is the answer?
So 278.5 into 10 to the power 3, sir.
278.
278.5
Then into 10 to the
into
power.
10 to the power 3.
So how many zero? Is it something like this?
Yes, sir.
Or another zero? One more zero.
One more zero, sir. Sir, I said 278.5 into 10 to the power minus into 10 to the power 3, sir.
So if you multiply by 1000, isn't coming like this?
Yes, sir. Now it's okay, sir. Yes.
Okay, ampere turn per meter.
Yes, sir.
So if you substitute this value 278
In that equation.
500, yeah, over there. Okay, here you substitute 278, then 500. Now what is the answer?
398.5, sir.
Oh, 398.
0.5.
398.5.
5.
Okay, if you go the 398, then 398 is here, and this is 398, right? And what is the
Yes,
difference? Hey, what is this calculation gives you? Yeah,
yes, sir. This gives you minus 0.37.
minus
0.37.
into 100.
Yes, sir. 100. I multiplied it.
After multiplication,
Yes, sir.
what is the value? 0.
Minus 0.37.
0.37. Okay, good. So it is within plus minus 5%. So the result is acceptable or not?
Acceptable, sir.
Yeah, it is within the tolerance. Hey, if all of you understand?
Yes, sir.
Yes, sir.
Yes, sir. Now, the answer is what? Can anybody tell me? Raise your hand. Raise your hand. What is the answer? Answer is what? 0 point? Tell me, anybody? Minus?
Yes, sir.
What is the answer? Raise your hand first.
So already there is.
You tell me the answer is what? Can you see the whiteboard? I think you can see the whiteboard. I have written the answer. Now you just tell me the answer. That the answer is, raise your hand and tell me.
So the answer is
0 point minus 0 point.
So what minus
No,
0 point, sir?
I didn't ask. Hey,
1.05.
listen, come on. I didn't ask you. Tell me the answer. I said you raise your hand, right? Okay. Only Jihad raise hand. Nobody understand what is the answer. Okay, I am asking you. The answer is 0.0 minus 0.375. Minus 0.37. How many of you agree with this? This is the answer. Raise your hand. Is it the answer?
No, sir.
Okay, Jihad, you tell them.
Yes, sir. The answer is 1.05 into 10 to the power minus 3 Weber.
So the answer is this thing. This is the answer. That for this phi, 1.05 into 10 to the power minus 3. I said we got the answer, go back home. Now you can go back home because it is satisfy the condition. The trial and error method is satisfied. So your answer is done. This is your answer. Why? Question asked for not 0.375%. Question asked for what? The question asked for what is the phi? What is find the value of phi? So the value of phi will be equal to 1.05 into 10 to the power minus 3 Weber. This is the answer, not the percentage 0.3. That is for our verification that it is within plus minus 5% or not. But this is not the answer. Answer is that one, 1.05 into 10 to the power minus 3. Good, Jihad, thank you. Now all of you understand. Hey, all of you understand the answer?
Yes, sir.
Yes, sir.
Now you are having a very bad luck, and that's why you got the answer in one shot. Unfortunate thing will be happened in the exam. Maybe I can say one of the guy got the answer here. Look at it. Some of you said 750. I have assumed, but some of you said 800 something. What is that? 850. Isa, you told me or what?
Yes, sir. I said 850.
850. For example, if you go in the exam with the 850, for example, all of you look at it very carefully. If Isa go with 850, then what could be the answer coming then? Let us go and see. Maybe it can be a different answer in that case. Okay, if it is not 750, if it is 850, Isa, can you calculate? All of you, Jahid also can help. And what will be the value? Not 395, 98.
Sir, 440.5.
414.5.
Okay, 414.5.
Yes, sir.
Okay, 414. Okay, now Then what is the percentage coming now?
%3.49%.
Or 3.49. Okay, 3.49 is still, it is acceptable condition. So you can also consider this is a acceptable range, even it is 850 you consider. Okay, good. But any for example, I'm just telling you, if you somebody say this is more than that value, let's say 950 for example. Yeah, no, 950 cannot go. It should be 0.35. It's been like that. In case I'm telling it, if it is going, some people can whatever value 900 and this value they calculated. Yep, or it can be smaller than that 600. You can go whatever. If it is somehow, I'm just telling you, if it is somehow you got the value, I'm telling you here, that is okay. Look at it. I considered here, what is that? Sorry, here. I considered here to reduce, hey, all of you look at it. We have considered here to reduce what? 30%, right? Remember? Because the error was 37.5% initially. Can you remember?
Yes,
Yes,
sir.
sir.
Okay, there we reduced, we assumed 30%. That is a big question. There is a big question. All of you look carefully. Here is the big game in this problem. Instead of 30%, if you consider here, most of you will do what? I'm just telling you. Most of you will do 35%. Most of you. Okay, we can reduce 35%. Or some of you can say, no, I want to reduce 40%. Some of you can say, no, I want to reduce 37.5%. Something like that. Nobody should go for 30% for sure. But you gone for 30%, got the result. But if you go for 30%, 35 or 40 or 37.5, whatever, if you consider, that means you are going to multiply here 0.3 will be multiplied with just 0.35 means what? 0.35 or 0.4 or 0.375, something like that. And this value will be different. If this value different, BT Tesla will be different, HC value will be different, and then you can see the whole scenario change. It is outside the 5%. It must go outside 5% tolerance. What I'm talking, if this is the thing happened, then you can, if you see this is gone, let's say above 5%, more than 5%, in case if it is gone more than 5% again, now it is 0.37 or 3.49. But if it is gone above, beyond 5% again, then you have to again reduce the, percentage. Then what will be the percentage? What if it is, let's say this is, in this case you get 13.49%. Now are you going to reduce on 13.4%? Maybe another 10% you are going to reduce from here? No, you have to do the percentage on the base one. Base one is here. Earlier you reduce what? You reduce 30% first time. Look, you reduce 30% first time because it was 37. Now if you see, the second trial give you the value which is outside the 5% range, then you come back here again, come back to this value, and instead of 30%, now you have to change to 35% or more than that, 40%, 37%, like that. Let's say it, common sense, you should go for 30%, 35%, because like that. Whatever, you can adjust it. It should be what? More than 30% or less than 30%. Definitely you understand it. It should, if it is more even, then it will be coming down some more. So it means Based on that value, you have to reduce the percentage, remember, not with the new thing or the first instant. And you have to redo the whole thing. That means if you have 30%, you reduce to 25% or 30%, 35% you want to go, then you have to multiply with this guy with 35%, and then redo the calculation for phi c new, or you can say in that case phi c new prime, and phi c new prime will be not this. Let's say this is not 30%, it will be 35%, and everything is changing. So your new phi c is giving new value, new value, new value, new value. With this new value, you substitute it again into the equation, and you see again within the plus minus 5% or not. If you substitute this new value, phi c new value and hc new value and bc new value and this hc new value, hg new value, if you substitute this and you see it is not within plus minus 5% again, then if you go for the same process again and make it instead 30%, 35, you can consider 40, and like this you continue trial and error until you get plus minus 5%, and your whole 3 hours gone, your exam finished, you cannot answer again. You got my point?
Yes, sir.
Yes, sir.
Yes, but you should not do that. I'm telling you, even you do not get the answer within plus minus 5%, after the second trial, I'm talking about the phi c new prime, one more trial, you do phi c new and another trial is phi c new prime. That is, initially you got 30% reduction, it doesn't work, then you go for maybe 35%. Still it does not work, it is not within plus minus 5%. Then you stop and you decide among the two value which phi you consider, phi c new prime or phi c new. Which one is close to plus minus 5%, that value should be acceptable. You got my point, and you get full marks. You understand my point? No.
Yes, sir. Understand.
Yes, sir.
So you are going to have two value, phi c new, another one is your phi c new prime, this two value, and phi c new gives you within this plus minus, it is outside plus minus 5%, maybe it is plus 13%, and phi c new prime, it is giving you 10%, plus minus 10% within that 30%. So 13% is close to plus minus 5%, or 10% is close to plus minus 5%.
10%, sir.
So you will say my answer is very close to this. This is your choice. Phi c new prime you have to go for. I'm sorry, this is not prime. You go for phi c new or phi c new prime. That one you have to decide from what is the error you are getting. Which error is close to plus minus 5%, that should be your decision. That will be the answer for your case. If you cannot do that, if you say no, this is the answer, then I will cut the mark, because it is close, is 13% error. This gives 10% error. Of course, any children should understand that. That one mistake means you should not, and marks will be reduced. I think this is the way up to 2 trial you should do in the final exam. You should not go more than 2 trial. If you got my point, you must get full marks, remember. After 2 trial, if you cannot get the answer within 5%, still you get full marks. So don't go for the 3rd trial, wasting time. Hey, all of you, everybody
Yes,
understood?
sir.
Good, excellent. So this is end of air gap problem, and I think any type of problem you can solve from air gap. Where should we get the air gap problem? Raise your hand. I'll give full 1 marks if you can correctly tell me. Raise your hand. Where should we get the air gap problem that is giving us very much close to the final exam question? Where should I get this sort of problem? Raise your hand. I'll give 1 mark. I'm telling you. No, raise your hand. Yeah. Okay, I want to see first whether you can really answer the question problem. Burhanuddin, you go ahead, Burhanuddin.
From sample set 7.
Yes, good. That is what I am asking you. So everybody should understand. It's a heart. It will go into your heart that sudden set question paper is very important here. That's why I'm giving 1 point here. I'll give it Burhanuddin, to be honest, because this is what I want to put in your heart, that the sudden set question paper is everything for you. If you go through that, you can see the air gap problem there. If you go through that, you can see the series parallel circuit problem there in the magnetic circuit chapters, in the magnetic circuit problem. So please solve all those 7 set question paper for magnetic circuit. That's all. Don't ask me, sir, please give us the practice problem. Anybody asking instantly, I'll shoot him. So everybody should go to the 7 set question paper. There is a lot of practice problem. Those practice problem you solve is your target now. Before the metric intermediate, you go for what? Test paper. Like that, this is the test paper you can think. So I hope that EEE201, I used to give this 7 set sample question paper. Never give it to others, remember. You can talk to the control people and other measurement instruments. Never, I gave nothing to them. But only you are the first, in EEE201, all of a new student in Tripoli. That's why helping you by giving this old question paper. So it's easy for you to cope up. So everybody please be prepared for it. Now all of you note it down. Farhan is going to send an email reminding me to circulate that we are going to have a class on Tuesday at 7 o'clock. Not class, it's a review class. All your problem you have to bring, we can discuss it. But I should ask you, I will ask you, did you talk to Tahmid? Please, Tahmid is ready to help you. So Tahmid and Fakhrul is there. You can also go through them also, please. And last resort, you come to me, no problem, but all on Tuesday. Those problems which is not solved by Tahmid and Fakhrul, please come back to me, because Farhul and Fakhrul is working here today, this semester, voluntarily for the ST for this course. So please utilize them. They are very good students, especially Tahmid can solve your first-hand problem he can solve. He was last semester, he was my TA as well. So I hope that, Burhanuddin, you raise your hand. Any question?
No, sir.
Okay, lower your hand then. Okay, now let's come back to the point. This is all about for the magnetic circuit problem, and I have sent everything to you. Now hopefully you all get the thing, and this is the end of the class today because time's up already. And if you have any question, very fast, because I have another class. If you have no question, then all what I am suggesting you to prepare for the final exam. And final exam, I hope that you remember, when is the final exam? You know that on 26th, I already circulated, and 9 o'clock at night. So all of you should be very careful and be ready with everything. I have sent the final exam cover page. You all please print it and write by hand. No printing by the computer will be accepted. I'm telling you again, last time you did for me, Tom, but in final, I'm not going to accept it. All of you please get a hard copy printout and write by hand and sign, because this is very, very important. I need to compare your handwriting as well, and your signature all by pen, not digital signature, not by printing by computer. Everything should be a blue pen, so that when you take a screenshot, it can be understood clearly that it is a separate pen you used.